the next part of the concept, I would like to explain some more concept which will be a base for the next concept to address. So prior to that, I will explain something that I have already given a hint in earlier videos. That is, any number can be represented with a geometrical figure made by dots. If I leave one, because one will be a single dot, and single dot doesn't mean any figure, because the least dots I require to even draw a line is 2. So with one I cannot explain, so better going to the second, or the number 2, I can represent with a line with the dots. The 3 I can represent it with 3 dot with the which will be a figure of triangle. Moving to 4, it is a square, definitely. 5, it will be arrayed just like a trapezoid if I add it. 6 further can be represented as a triangle. 7 again the repetition of, what can you say, a trapezoid, because this is the only option that way I can represent 7. 8, if I try to represent it, again it is kind of figure that will not give you much, rather I can give it a figure somewhat like that, or you can say I can put it like that. That will not be a perfect figure, but still it will give some kind of shape. 9 and 9, 1 2 1 2 3 4, 9, then again I can represent it as, because this is the compliance with a dot. With the 8 I can put a dot and make a square like that, as everything can be represented with a dot with some figure. If I add, this is straight line, this is a triangle, this is a square, this is a trapezoid, this is a triangle again, this is 7 would not give you much of idea. This is a shape, this is not a regular shape, that is same for, you cannot define any shape or mix of shape. Whereas 9, so like that every figure can be represented with the dot, and it will represent some figure. Now in this, if I see some numbers 1, 3, 6, 10 and all that, this will form particularly a triangular shape. Okay. And in this case you can see the number of dot per case, it is increasing by some pattern. That means here it is 1, here 1 plus 2, here 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4. So that means this kind of number is achieved by adding the two consecutive natural number. So if I see for generalize the thing, so any nth triangle must have 1 plus 2 plus 3 plus dot 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 n, because these are the summation of the natural numbers until the that much term, because here 10th is will be 10 row, 4 row, it will be 3 row, it will be 2 row. So the number of row it will need to complete the triangle maximum will be added up to that natural number. That means nth triangle, nth kind of triangle should have the last number added to is equal to the that term itself. So you know the sum of natural numbers is nothing but n into n plus 1 by 2. Now this is the first part. Now if I see similarly the squares, 1 square is 1, it will tell you nothing. 2 square is 4. Now 4 is represented by a square. That means 2 square is a square, because square have equal arm. So I can tell that this is 2, this is 2. That will give the result, give you 2 square. So any number square can be represented by a square, geometric square. So that way 3 square is equal to 9. So I can represent it here with 9 dots in a form of square again. Okay, square. Now same for 4 square, it will be 16. So similarly I can put 4 dots on all sides and it will represent a square. Now if I want to build some relation with this square and this triangle, can I able to do that? Now let me take this opportunity to represent these square numbers with some numbers. One has nothing prior, because this is 0. So 0 plus 1 is the same. 4 can be represented as 1 plus 3. That means 2 consecutive triangle. 1 is considered to be a triangle if. So 1 and 3 is the next triangle. This is triangle. This is the third triangle. This is the fourth triangle. So the second triangle represented by 3. 9, second triangle plus third triangle. Okay. Similarly, 4 square is can represent by what? It is 6 plus 10. So that means third triangle and fourth triangle. That means I mean to say कि any consecutive triangle or the number which is represented by the triangle geometrically is equal to the square of the natural number, any natural number. So that also can be represented with this presentation. If I take this 4, so the 4 square is 16, you know, that I have shown you. So if I draw it like that, and try to rub it. So this is a figure which is represented by one triangle. This is how much? 1, 2, 3, 4. That means 10. And another triangle, 1, 2, 3. So that means the result is 6 here. For this 6, and for this is 10. So 10 plus 3. So any square, then this result is equal to 4 square. So any consecutive triangle can be represented with a respective square number in respective square number, you can say. So I mean to say any square can be represented with consecutive triangle. In this case also, if I take the example of 3 square is equal to 9, so 9 again is a square. So 9 can be represented with the second triangle consists of 3 dots and the third triangle consists of 6. So 3 plus 6 will give you 3 square, that means 9, a square. So any consecutive number which can represent a triangle, if I add, I will get definitely a square number. I will get definitely a square number. That is the theory. It is depicting the truth. That same thing that theory is telling. So that has to be proved, and that is being proved. Okay. So the statement that I can tell that two consecutive number which can be represented with a geometrical figure with the dots, if being add, I will get a perfect square. Okay. So next come another theory where it is told that if 1 is added to the product of two consecutive odd numbers, will give a perfect square of even number in between. That means if I take two consecutive odd numbers and multiply and add 1 to that, I will get the square of the even number which lies between those two odd numbers. So let me take two odd numbers. I can represent a 2n minus 1, a odd number, then because for any value of n, because n belongs to a natural number, so any value of n, if you see, if I put it, I will get a odd number here, and the consecutive odd number would be differed by 2, so this would be 2n plus 1, because between two odd numbers there is difference, is consecutive odd numbers there is a difference of 2, and same for even numbers also, the consecutive even numbers are differed by 2. With the same concept, if I take in one odd numbers is like that, and this can be represented by any value of n, where n is a natural number, and then the next odd numbers could be 2n plus 1 divided by 2, and you can also take the previous odd numbers will be subtracted 2 from this, that will get 2n minus 3. So I am taking this one for the sake of the calculation. So these are the two odd numbers. Now I have to multiply 2n minus 1 and 2n plus 1. So this will give you 4n square minus 1. Now the condition is that I have to add 1 to this. So if I add 1 to this, I will get if I add 1 to this, I will get 4n square minus 1 plus 1. So this 1 will nullify each other. I will leave with I will left with 4n square. So that means it could be represented as 2n whole square, which is, and then you can see this 2n is a even number definitely, and it's a square of an even number. So the first thing is proved. Now where that 2n lies, because 2n minus 1, the next number will be differed by 1. So I will get the next number by adding 1 to this, and next to that I will add further 1 to this. So if I see what are the numbers? I will get 2n here and 2n plus 1. So you can see that odd numbers are the numbers, the extreme numbers to this number. Now this is definitely a even number and lying between these two, and here the result is 2n square. So hence proved, the one if it is added to consecutive odd numbers, the product of the consecutive odd numbers, I will definitely get a even square, and which will lie between these odd numbers. Okay. The next one is just opposite to that, and that also is true. Here, if I add, if one is added to two consecutive even numbers, then the result is a square of an odd number. Okay. Now let the first even number is 2n. Definitely it will be 2n. There is no doubt that 2n is an even number. And the next even number will be divided by 2, that means 2n plus 2. Now my thing is that I have to multiply these two. So let me multiply it. So what I will get? I will get 4n square plus 4n. Now condition is that I have to add 1 to this. So if I add 4n square plus 4n plus 1, you can see this is definitely a square of 2n plus 1 whole square, because this is nothing but a square. A square is 2n whole square plus 2 into 2n plus 1 whole square. So that means a square plus 2ab plus b square. Okay, so that will give you 2n plus 1 whole square. Now this is what? This is a odd number definitely, because for any value of n, which is n again lies between natural number, is a natural number. So for any value of n, 2n plus 1 is an odd number, and square of that is also odd. So this is odd square. Now where this 2n plus 1 lies, the next number to 2n will be added plus 1. So because the next number is differed by 1, so this is lying in between 2n and 2n plus 1 definitely. So this proves the theorem. Okay. So this is for now. In the next video, I will tell you more about the properties of numbers. Okay. Thank you.